This video is on key features of a function. We're doing example 3. Automobile industries must accurately report every vehicle's fuel efficiency. Customers compare the amount of gasoline a vehicle uses per mile it is driven. The graph below displays the amount of gasoline in the tank of a particular vehicle based on the number of miles driven. Identify the independent and dependent variables. Since we have a graph, we can easily identify the independent and dependent variables. The independent variable will always be on the x-axis, and the dependent variable will always be on the y-axis. So if we're talking about the independent and the dependent, the independent variable is going to be the miles driven. While the dependent variable will be the gallons in the tank. And don't forget that independent are the variables that we can easily change, and the dependent are the variables that are changed because the independent variable is changed. So the amount of gallons that are in the tank will change because of the miles driven. If you don't drive any miles, you're going to keep the same amount of gallons. So the miles driven is what we want to change, and then the gallons in the tank will only change because of the independent variable. Our next question is, how many miles have you driven if you have 8 gallons of gasoline left in the tank? So we have 8 gallons of gas. The x is the miles driven, gallons in the tank is on your y. So we want to look on the y-axis at the 8. We're going to go from the 8 all the way to the function itself. Draw a line over to that function. We hit the function, and then we're going to go down to see where it hits on the x-axis. Looks to be 175. So you will have driven 175 miles if you have 8 gallons left in the tank. How many gallons of gasoline do you have left if you have driven 125 miles? So we have 125 miles, that's on the x-axis. So we're going to go to the x-axis of 125, and then we're going to go to the function itself. So that's going to draw a line going up. We'll hit the function, and then we'll use that to go to the left to figure out where it hits on the y-axis. Looks to be 10. So there will be 10 gallons of gasoline left in the tank after we've driven 125 miles. Now it says to find the y-intercept and explain its meaning in the context of the problem. So the y-intercept is where it crosses the y-axis, which is right up here. It says 0, 15. So there are 15 gallons. Your y-intercept is at 15 gallons. And remember, the y-intercept is when nothing has happened, no miles have been driven. So before the vehicle is driven, it has 15 gallons of gas in the tank. That's in context. So before the vehicle is driven, it has 15 gallons of gas in the tank. Now, this could be one of two things. First, it could be that your gas tank will only hold 15 gallons. Or it could be that we only put 15 gallons in there and have not driven it. Most likely, it'll be that your gas tank can only hold 15 gallons, so we can't go any more above that. Although not shown, estimate the x-intercept. Explain its meaning in context. So if we were to continue going along this line, and we can actually see that every 25, so every gallon of tank, it comes over to 25 miles. So if I go to 50 miles, I've also lost another gallon. And if I go another 25 miles, I've lost another gallon, and then another. So I can actually follow that to figure out how many miles it will take for the gallons to reach 0, because we want to know where it crosses the x-axis. So if I keep going with here, I know that at 2 100, I'm at 7 gallons. So at 225, 250, 275, 300, 325, 350, and then 375. So we can actually estimate it should be about 375 miles. Again, I can see that for every gallon I lose, I am going 25 miles. So every gallon going down, I am driving 25 miles. So even though I can't actually draw this out because it'll hit everything else, I can see that if I go down to 6 gallons, I'm going another 25 miles. 5 gallons, I'm going another 25 miles. And then another 25, and then another, and another, and another, and another. And I'm just adding 25 each time to whatever I had last. So I'm at 200 here. That means if I kept going, I'd be at 225, and then at 250. And I could keep going, but it's a little bit easier instead of trying to draw it out this way. I can kind of count as I'm going down my gallons of gas. So again, in context, I know that I had to get down to 0 gallons, and that's what we're looking for. How many, when there's 0 gallons left, so there's no gas left in the tank, how far did we go? So when the vehicle has driven 375 miles, there will be 0 gallons of gas in the tank. So another way we can look at that is we can drive 375 miles before we have to fill up the gas tank again. We can go 375 miles on 15 gallons of gas. So F says find the interval over which the gallons of gasoline are increasing. Again, increasing is as you go from left to right, is your graph going up? So starting at our y-intercept, because it's our first point on the left, as I follow this line, it's going down. And we can see that it'll continue going down unless I fill the tank back up. But I'm not filling the tank back up. So there is no interval of which it's increasing. The gallons are never increasing. The gallons are never increasing. So then find the interval over which the gallons of gasoline are decreasing. So we can see that it's always going to be decreasing because as we started from here and we went along the line, it is going down. So when was the first time it started? It didn't start at 16 or at negative 25 miles. It's at 0 miles. So remember that the interval is with regards to the x. So as the x starts at 0 and it moves on to 25, to 50, 75, 100, it is decreasing. But it's hitting all of these values. So it can also hit at 15 miles and at 30 miles. It's not just at 25 and 50. This is a continuous graph, not discrete. So this would be that the decreasing is decreasing from x is greater than or equal to 0. Because it is starting at the 0, and it's decreasing every time after 0. So every mile driven, the amount of gallons of gas is decreasing.